think I'll get started since it's pretty close to 4:30. Thanks a lot for coming. It's been an excellent conference so far. I've never been to this conference before. Been involved with museums and computers for a long time, so I can't believe I have, but this is a fantastic event, so thanks to all of you for making it that way. I've had a lot of amazing conversations and gotten to see some old friends. It's great. Speaking of old friends, I'm going to be talking about Flash today. How many of you guys have ever used Flash before? Okay, great, cool. How many of you guys have ever used HTML5 or JavaScript or anything like that? Oh, excellent, great, okay. So before I get started, I just want to tell you who I am. My name is Bryan Kennedy. You can find me on Twitter there at xbryanx. That's just because I couldn't get Bryan. And I post about lots of things, music and JavaScript and museums and all kinds of stuff. Like I said, I work at the Science Museum of Minnesota, which is over in St. Paul. There's another city right next to Minneapolis called St. Paul, the Twin Cities. We are a big interactive science center, over 100 years old, with over 1 million objects and artifacts. While we are a hands-on interactive science center with lots of engaging media stuff, we're also a object-based institution who has Native American artifacts, natural history collections, big dinosaurs, all kinds of stuff. And something that a lot of people don't realize about the Science Museum of Minnesota is that we're also like one of the largest in-house exhibit design firms in the country that's actually based inside of a museum. The bulk of our work in the exhibit design and development group is creating museum exhibits for other people around the world. So we create both traveling exhibits that go around, but also do bespoke work for institutions in Dallas and North Dakota, San Diego, all over. So if there's any of this stuff that you see today that you want some help with, we'd be happy to talk to you and help you out. We've got facilities and talent and people who can help with that. I'll be taking credit for all of their work today. The other thing we do is try to develop open source first. When we start a project, we try to make the first line of code that we write open and on GitHub. GitHub, if you don't know, is an online site for sharing source code. The first 3 letters of that are a version control system called Git, which I imagine most of you know about, but I just want to make sure I'm not glossing over stuff. You can find us at github.com/scimusemn, and I'll show you one other thing. I've mentioned this in a couple sessions today. It's pretty informal. The Museum Computer Network also has a GitHub page with just this one repository in it, which is just a listing of museums who are doing stuff. If you're doing stuff out there that's in open source and you don't see yourself here, don't get offended. Just submit a pull request or email any of us who are on here, and we'll add you. Change this, mix it up however you'd like to see. All right, so we're going to be talking about moving on from Flash. If you walked into a museum 10 years ago and you saw any sort of interactive media, you could make a pretty good bet it was on Flash or its even older brother, Director, which are both from Adobe. As we're moving forward now, I'm going to be talking about why we'd want to move on from Flash and also how to move on from Flash. Before we get going, I thought I'd show this cute little video here just for a second.
Woohoo, check it out. I'm vulnerable and should be updated. Hey, that sounds like my dating profile.
Homestar, what are you doing, man? This is horse giblets.
Oh, hello, horse giblets. I thought you were just a filthy sack.
No, I'm not referring to the filthy sack, whose name, incidentally, is F-Sack. I'm talking about the situation, man.
What situation? I'm trying to update my dating profile.
Haven't you heard? Flash is dying.
Oh, well, good. I'm a way better runner than that guy anyways.
No, I'm talking about Flash. Like what we breathe. The thing what creates us all.
Strong man. If I didn't know any better, I'd say you were getting a little religioso on me.
Ah, see? That's a chunk of Flash authoring interface right there. It's falling apart. We gotta head for the hills.
Are those hills? I always thought they was bushes.
Figurative.
But actually, I never walked a couple of feet to find out for sure.
Meant it figuratively.
Hey, let's do it right now.
Being figurative.
Bush. Definitely bush.
Now listen, I've got a...
Anyways. Homestar Runner is a lovely little animated cartoon built in the heyday of Flash, which is still around a little bit here and there, making a comeback. But this video is sort of hinting at more of the web side of things that's going on with Flash. Obviously, if you're trying to make some things for the web, there's a lot of barriers to that. It's vulnerabilities due to security issues, and its adoption in various different platforms, like the iPhone not supporting Flash at all. What I'm going to be talking about a little bit more today is why we should ditch Flash from a in-gallery perspective. The majority of the work that our group does is developing multimedia experiences for in the museum and on screens, but also more unique interfaces as well. So why ditch Flash? One of the biggest reasons for me as somebody who needs to attract talented developers is people. If I don't know how many Flash ActionScript job descriptions you see out on the MCN listserv anymore, but I don't see it as much. I think as far as attracting talented developers and keeping those developers happy, Flash is not the tool to use going forward. The other one is community. I think if you're on GitHub looking around for code samples and interesting kinds of tools that are developed at multi-million-dollar software projects, like they're not built in Flash and ActionScript. They're built with tools like JavaScript for things like React and Angular and Meteor and Drupal and Bootstrap. It gives you a larger library to draw on to reuse code. The folks at Balboa Park were talking in a great session today about creative reuse of code. And while that was there was certainly a time where there was a lot of creative use of ActionScript code, in my quick searching through GitHub, I couldn't find any super popular ActionScript libraries that would allow you to do some of the innovative new museum stuff that we're seeing today. And I think the one thing I want to make clear too is that Flash isn't necessarily dying, it's just changing into an animation tool. Its main output might actually be more as a movie that then gets incorporated into either like a TV program or some other aspect of an animation project. And there's limited inputs for hardware support. One section of what I'll talk about a little bit later today is unique hardware inputs to your digital multimedia experiences. And the kind of kooky things that we're putting into our digital media experiences wouldn't necessarily work in Flash. So I'll move on from bad-mouthing Flash and start talking about why HTML5, and what I mean by that is great. So to give you an example of what I'm talking about when I talk about a digital media interactive that we build is something like this. So we built an exhibit about space and why you'd want to go to space, why it's so dangerous to go to space, and what we can find there. This is a little component in there called Powering Your Spacecraft. It's a little simulation game where you get to play with all the elements of keeping yourself alive on a spacecraft and see how they work. And these switches down here, which I can't remember if I have. Let's see, let me skip ahead here. These switches down here are actually the only inputs to the game. There's no touchscreen or anything like that. So as you switch back and forth between the battery or switching something over to a solar panel, you can control the inputs of what's happening up here on the digital game. Those kinds of unique inputs wouldn't necessarily be possible in Flash, and I'll talk a little bit how we're getting those kinds of things into HTML5. All right. The one thing I'm not necessarily going to talk about is how to build HTML and JavaScript applications. There's a lot of resources out there on the web on how to do all that kind of stuff. What I'm going to talk about mostly is weird edge cases that we run into that I haven't found as much support for outside of the museum world, because when you search on something like Stack Overflow or other user forums, the main answer is like, don't do that. Why would you want to do that? And the answer that, but we're in a museum, it's weird, isn't really something that other people really get. So one of the challenges we run into is what is the delivery mechanism for HTML5 and JavaScript applications? It is the browser, right? So what browser are you going to pick? How are you going to turn that into a safe and working experience that's on the museum floor and not looking like this to your visitors, right? You know, if you've got a browser up like this, there's a couple things that your visitor could do here which are not great. They can come up here and open up new files. They can do what I just did, which, you know, like all of a sudden get into the system stuff. They can close this down. They can type in Facebook into this thing. Obviously, there's a lot of things we want to prevent them from getting into, and we want to turn it into an experience that's a little bit more like this, a defined, you know, singular image. So one of the ways that we handle this is by primarily using Chrome as a browser. Chrome is cool in some ways, but it has its own problems. All of the browsers have some problems, and I'll describe sort of what some of those problems are. True full screen. What do we actually mean by that? You know, this page right here, right now, is run in a browser. This thing that we're looking at right now is a browser, and I've made it full screen. But imagine I'm a user and you've attached something as ridiculous as a trackball or a mouse to that, and then I do something like this. Does everybody notice how I just moved my mouse all the way up to the top, and now I have access to the full menu bar and all those kinds of things? That is surprisingly, it's a really unexciting problem, but it's surprisingly difficult to prevent from happening on various different hardware platforms, whether you're putting your browser out on Linux or Windows or Chrome. You tell this thing to go full screen, but if you go out on Stack Overflow and say like, hey, how do I make the browser go full screen and not be able to get to any of the other parts of my computer? People are kind of like, well, why would you want to do that? You know, like you want to be able to get to the other applications on your computer. And we don't want our visitors to be able to, because obviously then they're going to go in and change, you know, the IP address of the computer for some reason. And the other thing that can happen is, and I bet you guys have seen this in several sessions today or over the week or in some conference somewhere. If I had a background sort of like process giving me a notification anytime somebody mentioned me on Twitter, or a background process telling me that like, hey, El Capitan is out. Do you want to upgrade? Those kinds of things can pop up in front of a full screen browser window. In fact, we see that happen all the time. Different software background processes can come in front of it on a 3 p.m. on a Tuesday, and a fifth grader is like, sure, install El Capitan on the touchscreen, you know? And then, you know, obviously you've broken out of the museum and gallery experience. That's something you want to actually prevent. So how do we do those? How do we fix those kinds of problems? I'll get to that in a minute. Another problem is that browsers are really paranoid for very good reasons. They don't let the web page inside of the browser do some stuff that you probably want to be able to do as a museum experience for a very good reason. You don't want Facebook.com to have access to your files on your system. Well, sometimes you might because you actually want to upload photos, but you don't want most websites to have access to the files on your system. But if you're designing HTML content, you very well might want to have access to a video file that's on that system or any other sort of files that are on your system. The other thing you probably don't want a lot of times is HTML content that's out on the web in general to have access to your USB devices or serial ports or things like that, or webcams. But in many HTML developed experiences, you do want that. The other problem is that browsers aren't paranoid enough. In many of the experiences we develop, we're asking for user input. There might be a form that says like, hey, tell us your email address and we'll send you a copy of the picture that you just took and did with this experience. Well, let's say you type that in. And in a normal browser experience, the next time you come back to your browser and you type the first part of your email address, your browser is going to be like, hey, let me help out and complete your email address for you. When you're using a browser in gallery experience, you don't want that to happen, right? Because 100 people have come along and typed in their email address, and now anytime you start typing an email address, you're publicizing everyone's email to everybody else. So you need to be clearing that kind of stuff on a regular basis. And, you know, what is, the question I have up here is sort of what is a session, right? Many times when we're doing in-gallery experiences, If you're on a computer and you're using a browser to go out to the internet, a session it sort of always assumes that the ID of that browser and the IP address that you're browsing from is a human being, right? So like Google Analytics and things like that work because if you're coming from a identifiable sort of network place, that's a human being. Well, how do we attribute a in-place kiosk that's a browser in a gallery to a sort of a digital signature or on a browser a session? We've got to think about that. And then what do we do with edge cases like people getting out to websites that they're not supposed to, right? If you have a gallery-based browser-based experience and you want to activate some sort of internet aspects of things, you want to go out to the network for some things, how do you make sure that visitors never get out to sites like YouTube, where you can imagine every 5th grade boy is going to type in something inappropriate pretty quick? All of these sort of edge case problems that I'm talking about are things that we have experienced over the last 5 years trying to put browser stuff in the gallery. We have had people email us and say, hey, I just saw somebody see my email address out on the floor. Like, that's unacceptable. Like, they thought it was unacceptable, we thought it was unacceptable, and we got to make sure we retain that kind of trust and safety. We got on the news one day because a grandma brought her grandkid to school, or to the museum, and in the Dead Sea Scrolls exhibit was able to get out to YouTube, and instead of leaving a comment about the Dead Sea Scrolls, was watching like bikini videos. So these are all the kinds of things that we have to be careful about trying to figure out how to do. So what are some of the tools that we use to address some of these kinds of problems? One is a tool that we built. So this is up on our GitHub page. It is moderately well documented, both in the code, but also with some descriptions on the README page. It would require a little bit of technical know-how how to use. I'd love it if more people found this useful and we could respond. Feel free to send questions or put in issues when you don't understand something about it. It's called Stella. The reason it's called Stella is we developed when we were building an exhibit about the Maya, and we just needed a name for something, and we thought that'd be fun. Stella is essentially just a set of wrappers around Chrome. One of the cool things about Chrome is that even though it allows you to sort of do all the default, you just open up Chrome and it's got all the security protections that you'd normally want for online, it has literally hundreds of flags that you can use when you turn Chrome on. So if you use the command line and launch Chrome, you can say like, run chrome.exe/ I don't care about security. Or, chrome.exe, it's totally cool if the web page has access to my webcam. And Stella makes that easy to script and make it launchable. The other thing that Stella has built into it is a couple sort of background processes using, there's a software tool called Selenium, which is designed for doing web testing that essentially will sort of run a browser for you. And what Selenium will do is sort of sit in the background and just sort of check to see what the browser's doing. And so Stella can interface with Selenium and say like, whoa, 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 every second. You're not supposed to be on Facebook.com, and revert back to the main homepage. Or it can say like, hey, nobody's been using the thing for the last 30 seconds, and revert back to the homepage. So it's sort of like a control mechanism for the browser a little bit. It doesn't handle every case of thing that you can ever imagine. It's pretty much a tool to scratch our itches, but I'd love it if it's useful for other people to scratch your itches too. So there's Stella. There's a couple other things that have been in development recently that we've done some experimenting with, less successfully. One is called Node Webkit. Part of the reason for these kinds of things that have started to emerge is because much bigger teams are starting to do this kind of work to build applications. How many of you have used Spotify on your computer? Okay, a couple of you. That Spotify app is an HTML application. It is built in HTML, and there's a ton more complex code behind it all the way. But the main wrapper of what you are using is a HTML application wrapped into an app on your computer, whether it be Windows, Linux, or Mac OS X. So Node Webkit is an example of one of these wrappers. It's an attempt to turn Webkit, which is sort of one of the engines that lies underneath several of the browsers, into an app generator. And it allows you to generate a sort of local set of HTML and JavaScript and images and all your media assets into an executable that can run on Windows and Linux and OS X. Remember when I talked about true full screen? This one doesn't handle that super well. I just haven't had as much luck with it. There's an open issue queue in this one and in the next one that I'll talk about completely true full screen, and people are trying to figure it out. Here's another one called Electron. Electron, if you've used any stuff from GitHub, how many people code in the Atom code editor? Crickets. Okay. It's like Spotify, but imagine instead of writing code in a traditional application, you're writing code in something like this, and it is it's just an editor written in HTML and JavaScript and a bunch of other stuff, but it is a wrapper built in this software called Electron. And Electron has all of the sort of weight and amazing software power behind GitHub. It's developed by the people at GitHub. It's entirely open source. But again, there's an active bug that I have comments on about it not being truly full screen. So anyways, just something to consider. Stella for us works, and it works pretty well. All right. So I mentioned earlier about that powering your spacecraft thing, where you turned knobs to make things happen in a web page. It's probably been a little while since you used any knobs to control your web browsing. So I'm going to talk about how we get unique hardware interfaces that you might see in a lot of science museums, like buttons and knobs and sliders to control stuff in HTML and JavaScript web pages. This is a button from like one of my favorite exhibits in the world at the Boston Museum of Science, Mathematica. And I just love that, this is like a science museum button designed by Charles and Ray Eames. So before we get to the technical aspects of the hardware interfaces, I wanted to talk for a second about what do we mean when we talk about hardware interfaces? What are the motivations for trying to interface with a digital experience through hardware? I think one of those is just real simple. It's just interface control, right? You want to go next. You want to see the next picture. You want to click on something. You want to move a character. It's pretty simple, straightforward stuff. The other thing you might want to do is input data. Get more complex information from the person, whether that be like, tell us your name, or like, tell us a story, write something down with a keyboard. Or maybe you've got even a more complex input mechanism, like a heartbeat sensor. Like if you have a pulse oximeter that you could put on your finger, and that could read some sort of information into the system. So data input. And then maybe even more complex, which is technically a type of sensor, is some sort of media and motion capture. And here I'm talking about taking in audio inputs, or imagery, or even using movement as an interface. And I'm sort of paraphrasing for Kinects here, right? Everybody's seen some experiences where you get to spread out your arms and control a character on the screen by moving your body around. So how do we get those kinds of motivations for input into a digital media experience using HTML5? One of the simplest ones that we use is a family of hardware called keyboard encoders. This is the keyboard encoder right here, this little guy. These wires are running up to a button. It's a joystick with a trigger, and when you pull the trigger, it completes a circuit, connects that circuit, and goes to this little guy, where we have a very simple programming interface. This is called a Hagstrom keyboard encoder. This is maybe a company called Hagstrom Electronics. There's a simple GUI interface for programming these things. And you'll notice right here, this is just USB. And the USB goes to the computer, and the computer just sees it as a keyboard. So when you pull that trigger on the joystick, you're just saying, hit the A key on the keyboard. And it's very easy to build HTML and JavaScript applications that say, like, when you press A, do something in this application. So that's the main way we would do this. And you can imagine if you've got a keyboard, you've got, like, quite a few inputs you could map to things. So in the Journey to Space exhibit we were talking about, those switches that that triggered between all those things, each of those switch locations could have been a keyboard key on this thing. For complicated reasons, they aren't, but this is the simplest level of where we take hardware interfaces into HTML. So like if you wanted to get a revolutionary concept to appear, just press this button. I skipped this slide here. The next one we sort of start to think about are touch screens, right? So touch screens are very prevalent in museum experiences, or at least interactive one. I'll talk a little bit about keyboards and mice. I feel like there's fewer and fewer science museums where you'd see a trackball or a mouse. I haven't seen one in an art museum or in a really long time. But touchscreens are very prevalent. How do we control touch interface into HTML? Great. One of the key things that we use is a JavaScript library called hammer.js. This is a, does anybody get the reference here? Why a touch library would be called hammer.js? You can't touch this, MC Hammer. Anyways, that used to be the motto on the homepage here. What this does is takes multiple points of input, whether a singular touch input or multiple points of input, and turns them into gestures that you can make happen in your JavaScript programs. Interact.js is another one that allows for some more complex multi-touch inputs. In our testing, I've taken some multi-touch screens and gotten up to like 16 points of input working on a HTML5 application. And I'm sure there probably could be more. The limits are based on what sort of you want to do based on the input of all those points. And there's another one called Gesture Kit, which I haven't really looked into that much, but I just wanted to mention it. The other big one for us is Arduinos. So Arduinos are little microcontrollers, just little computers that allow you to take lots of different sensor information and input it in as serial information into the computer via USB or a network interface. So we use, I'll skip over this for a second. We use a background process running in the background, generally programmed in Node, and communicating with the HTML application in WebSockets or Socket.io, which are sort of synonymous, to take information from the Arduino and a little processing sketch that is running on there, and then channel it over the network to the HTML5 application. So an example of that would be like back in that powering your spacecraft activity. The powering your spacecraft is based around the idea that you sometimes go behind the Earth and the sun is blocked. There is a series of lights and solar panels that actually generate your electricity that feeds into that program. And we needed to get that solar panel information into that HTML application. So that solar panel is outputting an electrical current, which then goes into the Arduino, which is then fed into the Node application, which is then put up into the HTML display. There's a lot more detail there, but for time, I'll just leave it at that schematic, and you can bug me if you want to know more details about how we get that to work. And like I said, there's 2D and 3D cameras. Stella gives us some control to be able to easily pull in webcams. We're using commodity webcams, just like a little Logitech webcam, to do a lot of image capture and video capture, pulling that in, saving that on the local hard drive, and then putting that up into a HTML display. Works great. We've done Connect stuff primarily through non-HTML ways. I've seen some code out there that would allow you to pull HTML data into, Connect data into HTML display, but I have not done much testing with it. So I mostly just wanted to say that it seems like it's technically possible, but maybe not the best way to go about doing it. All right, so in interest of time, I thought I'd see if there's any questions at this point about this myriad of technologies and acronyms I've thrown at you guys. And maybe I can continue on from there if people are curious about anything that I've said. Yeah. Yeah.
I have a question. Do you have any communities of other people who are doing this kind of development work at different museums that you go to for this kind of information? Like, what are your technical resources if you're looking at, our community in terms of where you share this knowledge?
Maybe I'll.
Sorry, could you also repeat the question?
Oh yeah, sorry. I'll actually pass around the mic next time. She was asking if there's a community of people that we go to for for helping us sort of generate ideas and also solving technical problems with this. Maybe one of the first communities I would say that we really go to is Stack Overflow. Stack Overflow is a website online that's just sort of an answer and question website, and we use that a ton. But then I would say ask around about other folks that are in this room who are doing that kind of stuff. I think we saw some interesting stuff from Balboa Park. We've got a lot of people in house that we do stuff with. So yeah.
I guess I meant specifically in the museum, the physical space community, just in general. If there was any sort of place that people shared there.
Yeah, MCN mailing us for sure, absolutely. No, people are really asking and answering a lot of those kinds of questions there. Yeah. All right. I want to be respectful of time too. Yeah. I think we're butting up into the next session here. So, all right. Maybe one more question and wrap up there.
I was just kind of curious about what kinds of devices you're using and whether they're, Windows or Mac based.
We default to using Macs only because we can get Mac Minis pretty cheap and they're robust and easy to ship across the country. And you can configure a Mac like Linux for the most part through the command line. But we use Windows when we need to, and we use Linux when we need to, but primarily Mac Minis. Yeah. Cool. All right. Thanks, you guys.
All right, hi everybody. I'm the second improvised moderator, so I'm just going to cut to the chase. This is Michael Walter. He's from the Cooper Hewitt. We used to work together. He's going to talk about the pen and all the stuff that the pen produces.
Yep.
And the data. All right.
Great. Thanks for coming. I'm sorry about the confusion over the room. Here we all are. This is awesome. And so let me just clear up a few things. Pam Horn, my colleague, was originally supposed to do this talk. She is the one that submitted it, but she couldn't make it, so we talked and agreed that I would hijack it. That said, it's not going to be quite what's described in your menus. It's it's not going to have anything to do with publishing, because I don't really do much of that. And it's not going to have a ton to do with the pen, so if you want to leave, that's okay. I won't be offended. We'll talk about the pen, but it's going to be really more about a general approach to how you approach something like the data that the pen produces or some other system that's similar. Let me see here. Yeah, so I guess it's probably worth pointing out right now that we've been open, the Cooper Hewitt has been open for almost a year, actually, coming up on a year in December. And we have had the pen in visitors' hands for about 7 months now. So just think about that for a second. It's really that we're just getting started, right? And I wish I could stand up here and teach you all something like that you could take with you, take home, come into work on Monday and plunk down on the table and say, Micah told me this amazing thing at the conference, and now we have it all figured out. And we can move forward with our projects and do the things we want to do. But I can't do that, right? And that's okay, because the fact that you are all here, the fact that you are in this room and interested in what's going on with Cooper Hewitt and the pen and data says something by itself. And I congratulate you. Thanks for coming. I salute you, because this kind of work is actually really hard. And we're just really getting started. We're babies. We're infants. We're really naive about all the things that we're trying to do in a certain way. We have a lot of opinions and ideas, but we are just getting started. We've only had the pen out there for 7 months, and we're just starting to make sense of it now in a really small way. So we're not going to look at lots of charts and graphs. I'm not going to tell you amazing whiz-bang statistics that make the pen sound really awesome. I can do that all day long if we like, but that's not really the purpose of this talk. The point is we don't really know what we're doing yet. And one of the things I think about that is that on the other hand, it's kind of nice. It's nice to be sort of innocent in this space. It's nice to have a kind of naivete about it. Is that the right word? Yeah. Sure. So basically this talk is about some of the things I've learned along the way. And one of the things I've learned is that data is kind of tricky. It's kind of mysterious. It's kind of odd. It's there to help you find your way. It's there to explain things to you. It can be used to great success in that way. But it can also be really misleading, misguiding. It can blur the lines of reality a bit. Depending on how you look at your data, depending on what you do with it, you can really fall into a false sense of reality. And you can fool yourselves. And we do this all day long at Cooper Hewitt. We try to figure out the answer to a question, and then we sort of latch on to it. And we say that this thing is good because we know the data says it's good. So let me see here. So these are some of the things I think about when I approach the data, when I start to think about how to analyze it, what to do with it, what kind of tools to use, and that sort of thing. And I ask myself questions like, what are we really looking at? What is the data really telling us? And are we in that sort of false sense of reality sort of situation? So I'll kind of back up a little bit and stop and think about where the data actually comes from and what the real purpose of it is from the get-go. One of the things that I hear a lot is that the data will save us. That's kind of the pseudo name for this talk. And you get questions like, how can we use this data for marketing purposes and that kind of thing. But the data was created for other purposes altogether. For example, we have a lot of systems that are connected together that run the Cooper Hewitt, the pen, our interactive tables, our API. All these systems sort of are what we call loosely coupled together. And the idea behind that is that if one of them goes down, or if there's a network problem, or DC shuts the lights off for a day or something like that, the things that people are doing in our galleries can be replayed. We have logs, we have data that supports all the interactions that they did in our galleries. And so even though they might have a little bit of a delay before they can see the stuff that they collected, we can probably eventually get it to them. And so these are some of the reasonings around why we actually have the data in the first place. They're sort of diagnostic tools. There are ways to debug our code. There are ways to make sure everything is talking to each other all the time, that sort of thing. And I think that's sort of an important distinction because we don't build all the data into the systems we have with the intent of trying to figure out how to use it later on and make sense of what our visitors are doing in the first place. That's not really the motivation. I forgot to mention I just put these slides together this morning, and it's a little off my game here, but bear with me. So I'd like to talk about a few myths around data, because I think this will be fun. And you probably have heard some of these things before. One of the buzzwords that's in the industry right now is big data, right? We all think we have big data. We're big museums, we have big data. That's not true. We have medium data. If you think about Twitter and Facebook, the US Census, the NSA, those guys have big data, right? That's real big data. We're like pretend big data. And maybe one day we'll have big data, maybe that will take place, but it's not now, right? We don't have to really worry about it that much yet. But we can talk about it all we want. What's interesting though is that the tools we can choose, the things that are available to us to play with our data are the same things that are available to play with the big data, right? So all the different kinds of analytics tools that are out there, different kinds of databases, a lot of these things are open source and free, some of them are very inexpensive. They're there for us to start working with now. so that maybe like years from now when we actually start producing big data, we'll be able to scale the things that we're working on today. That's one of those myths. Another one is that if you have all the data, you can make informed decisions, right? So I was talking yesterday in another talk, very similar to this one, without the cool black and white photos, about how we can look at our data and decide if we want to change exhibitions around based on it. Those sorts of things are all on our minds, how we can come up with answers to the questions we have and make informed decisions. So let me get a show of hands in here. How many people in the room have ever used Google Analytics? Okay. Keep them up, keep them up. How many of the people with your hands up have ever made an actual change to their website based on something they learned from Google Analytics? Be honest. Okay, so a few, and that's great. But the point there is that it's really difficult, right? You can create ways to analyze your data. You can build tools around it. But actually coming up with an answer to the question you have and making a change based on that question is really complex. Right. So, another myth. If we put all the data in one place, it'll start to make sense, right? So this is sometimes known as warehousing, where you get all your different siloed data sets and stick them into one place. And because they're all in one place, you can start to look at them holistically with a 360-degree view, all those kinds of things. But what I found, and I've been trying to do this myself, is that once you start doing that, it also is still just as complicated. When all the data is in one place and you're looking at it as a whole, it's overwhelming, right? It's all right there. So it's not a magic bullet, right? It doesn't actually fix the problem, right? You can put all your data into a warehouse like Amazon Redshift, which is what we're playing around with, and you can figure out ways to do that on a periodic basis, so it's all there for the taking, but that's not the end of it, right? That's not the thing that's going to help you, really. Yeah. So I'd like to kind of switch gears from the myths into some of the tools you can build around data. There's a really great book called Data Smart. It's by John Foreman. And John Foreman is the chief data analyst at MailChimp. So he deals with big data, like real big data. And he's written this book with the point being that you can use really simple tools to look at big data sets, like Excel. What's really nice about Excel is that every single person in this room has Excel on their computer. Everyone in your museum staff probably has Excel on their computer. It's one of those tools that's ubiquitous and that people understand and know how to deal with from a really wide variety of perspectives. So if you're looking for tools to work with your data, Excel is a great place to start. It's really easy to share your insights. There's a way to have a dialogue with someone who might not speak your own language, but can look at an Excel spreadsheet and quickly make sense of it. And that's the point of his book. I recommend you check it out. Beyond that, there's all sorts of other tools, right? There's lots of existing tools. There are things like R programming language. There are things like Python, which is really fun to use for data. What are some other ones? There's Google Analytics, for example. There's tons of stuff already out there that lets you do these kinds of things. From my point of view, they don't really quite get you to where you want to be, so there's probably work to be done here. So at Cooper Hewitt, we're starting to build some of these tools internally. We're starting to look at what it would mean to try and share our data with the rest of the staff. So we don't have a data analyst on staff. We don't have a real easy way of expressing to the whole staff what kind of sense we're making out of the data beyond walking into like a senior management meeting and showing a PowerPoint slide. So beyond what you can do with Excel in that way, we're looking into building tools that will let us share this information throughout the museum more easily. So I mentioned we're working with Redshift, right? Redshift, if you don't know what that is an Amazon product. And just like lots of Amazon products, it's super simple to set up, right? You just log into your Amazon account and create an instance. You pay by the hour. It can handle petabytes of data without problem. And it's super scalable, right? It's a columnar database, and what that means is that it's sort of the opposite of what a traditional MySQL database is, where when you do queries on really complex joins and complex, really compacted queries, it's very fast. It caches the response, and it's super efficient in that way. So it's sort of perfect for working with giant data sets, and a lot of companies are messing around with it. What I really like about it is that it's really easy to spin up and start with. So it's a fun way to get into it a little bit beyond something that you can do with Excel or Python. It works with a Postgres client, so if you've ever messed around with Postgres, it's familiar. You can just use your Postgres client to connect to Amazon Redshift and do things like type SQL queries into it. We've been looking at all sorts of other tools that are built on top of this. So there's a few companies there's one called Periscope.io and Chart.io. And these are analytics tools that connect directly to your Redshift instance. And it's sort of like Google Analytics. It allows you to create charts, or it allows you to build queries very simply, really quickly. The problem I've had with these so far is that they're very, very expensive. They're prohibitively expensive for us at the moment. Maybe someday we'll have the means to use something like that. But for right now, we're sort of building these things internally on our own because of that. So, whoops, yeah. I had thrown an Aaron slide because, he does this kind of stuff. So what was I going to say about this? Okay, so this is the part where we get into actually doing the work, right? This is the hard part. And this is where we need people like Aaron and other engineers to come in and do the typing. So one of the things that's difficult about Redshift is that it is just a straight up SQL kind of language, right? And I think there's maybe 2 or 3 people at Cooper Hewitt who know SQL a little bit. And our director of marketing doesn't know SQL for sure. So we need to build tools around the Redshift database that allow other people to make these kinds of queries and other people to be able to build their own dashboards and start answering their own questions. And this is really difficult. So what we've been doing so far is building kind of an interface in the form of a website, right? So we have a web application that talks to Redshift, just the same way the collections database talks to MySQL. And we can start building pages and pages of different kinds of queries. So one of the ones that I did recently was a way to look at the way our different departments have changed over time by acquisition date, that sort of thing. And eventually what I would really like to see is that we can build these tools so that someone like a curator can log in and look at the pen data and look at ticketing data and look at web analytics and create their own queries and their own dashboards and that sort of thing. It's a long ways off, but this is what we're trying to do. Okay, whoops, whoa, hello. Hold on a second. I lost my mouse. Just a second. We were here. Okay, sorry about that. So that's where we're at right now. Hang on a second. And so now let me just start to talk about how we kind of progress here a little bit and some lessons we've learned along the way. We're still really just children, right? We don't really know what we're doing. We're just messing around here with our data. The pen produces lots and lots of data. It produces a row of data every time a visitor taps it to a label. But beyond that, it also produces lots of log data, so all the API interactions, all the server messages, all those sorts of things are logged and they're put somewhere safe. And so as we kind of grow up with this data, as we start to kind of think about what we can do with it, one of the things that's really important to me and important to the Smithsonian is that we do it in a proper way, in a good way, and that we become good data citizens, right? So things like we've said in the past other talks, to not be creepy about it, right? To make sure that the things that we're building, the tools that we're using to look at our data don't break the agreement that we have with our visitors. So an example of this is, and when it comes to our Redshift experiments, is having to do with our ticketing data. So we use the Tessitura CRM, and that is stored in a PCI compliant, behind a firewall, safe within the warmth of the United States government. And we do that for a lot of reasons, mainly to be compliant with PCI, right? And that's where all your personal information is held. So identifiable information, your email address, your your account information, the number of times you've been to Cooper Hewitt is all in Tessitura. And so if I take the Tessitura data and try and push it into Redshift, which lives in Amazon, I have to be careful. I have to say to myself, should I really be doing that? Because now I've sort of broken that compliance. I've done something that's probably not okay. And so we're starting to look into ways to anonymize the data, to obfuscate it, and to make it still as useful, but in that place that's not behind the PCI compliant firewall. So we really have to think carefully about how we build these tools and how we protect our data, and how we are still able to be nimble and still able to develop these kinds of things without being kind of bogged down by the fact that we have to follow all these rules all the time. So there's a tension there. So these are kind of like growing pains, right? We're working this stuff out. Another thing that I've learned is that data can be beautiful, right? And there's a yin and a yang to that too. There's a sort of, it's a double-sided sword, or whatever the right metaphor is. Data can be super beautiful. You can take the data that the pen produces and make an amazing visualization of it, and then you can bring it into a meeting and show everyone and say, look how awesome this is. And the thing about beautiful things is that they're really powerful and they are impactful, and people remember them, right? And so if you do it wrong, if you express the wrong thing, or if someone interprets it in the wrong way, all of a sudden you've created this very powerful, impactful visualization that is embedded in someone's mind now and might not be what you were originally trying to do. So think about that. Data can be beautiful. Beauty is not always what we want. And then this is a big one. Beware of the data nuggets. Okay, this is a term I came up with a few weeks ago, maybe a couple months ago, which is, you probably have all created a data nugget in your life. One really obvious data nugget is page views in Google Analytics. Why do we need to know how many page views there are on a website? What do we do with that piece of information? And what happens with these data nuggets, it's one of those things where you're sifting through the data, you're working with it and trying to tease out information, and you come up with this number, this statistic, and then maybe a little prematurely, you run up the stairs and show everybody and say, hey, 35% of the people that use our pen are not going to the website. What about that? Or, you come up with this little nugget of information, and then people latch onto it. And then from then on, every day, it's, hey, can you update the data nugget? I need to know the current stats on the data nugget. So be careful there. They're everywhere. So there is more than just the data. And this is probably the most important part that I've learned with looking at the data of the pen and all the things that we do at Cooper Hewitt, is that the data itself, the data by itself, is not enough to build a complete picture of what's going on. And one of the things that I like to do is I like to go into the galleries as much as I can and see what people are actually doing. Because even if I can tease out some behavioral pattern in the data, I don't really know for sure if it's necessarily the case. It's very powerful because it comes from data, and it can really influence people, but it doesn't always give you the full picture. So observation, going down to the galleries and watching people use the pen, watching people interact with our interactives is super important. And figuring out ways to build that into the way that you're sharing the data with the rest of your staff is one of those things that we're really struggling to figure out how to do. How do I present a graph to somebody and right alongside it have a way to say, well, this is what the data says, but when I go down to the galleries, I see X, Y, and Z. And how do you, at scale, do the observation kind of stuff? So this is a challenge for all of us, but I think it's really important to always be thinking about that when you're getting into analyzing data. Okay, so what have we learned? We're all grown up now, right? We all understand we're going to go home and start analyzing our data, right? We learned that the data won't solve all of our problems. It's not a magic bullet. It's not the thing that it's not going to answer all of our questions. We learned that the data is created for lots of reasons. Like I mentioned, we create data not for the purposes we always want to use it for in the end. One of the things I forgot to mention is that there's an interesting analogy there to our collections metadata. The reason collections metadata was produced in the first place was for inventory tracking and making sure we know where things are at any given time. But now we put it all on our website, right? We put all of our collections data up on the web, and we're interpreting it in different ways. And so understanding that the source of the data is different than what we actually might want to use it for down the road is super important. We learned we have a responsibility to our visitors. We need to make sure that the things we do with our data are appropriate and that we're not breaking that social contract or those terms of service that we have with our visitors. That's super important, something to always be thinking about. And lastly, I think just to sum it up, we're still pretty childish when it comes to data. And I'm not just talking about Cooper Hewitt. I'm talking about this whole museum industry, all of us. We don't really know what we're doing yet, and that's okay. The innocence involved in that might be a good thing. And that's kind of it. I'd love to take your questions.
You have a data nugget for Micah.
How do you manage to stay impartial when analyzing the data, or do you even worry about that very much?
I worry about that every night when I go to sleep. It's one of those things.
Me too.
Yeah, that's the thing, and that's what I'm sort of trying to get at here is that the data can really influence people before you know it. So we have I'll use the data nugget example again. We have a list of those things that people are always asking for, and the reason is because we just kind of pluck them out as things we have answers to. Being impartial around the data is a mystery, right? We don't know what we're doing, and so when we look at the trend of how one aspect of the data might look, we have to make assumptions, and being impartial to it is confusing, right? It's really stressful, I find. So it doesn't really answer your question, but that's one of the things that's on our mind.
Okay, then kind of a follow-up one. Have you ever used third-party companies to analyze your data for you to stay impartial?
No, that's a really excellent question. We're getting ready to partner with a company to do some survey data, to generate some data about our visitors, some user research type of stuff. And I think that's a great point, that the fact that they're a third party might kind of help us not be so heavy-handed in what we do with that.
So you mentioned that you don't have a data analyst, but you're jumping through some pretty serious hoops to put data in the hands of people who, untrained, might be prone to lots and lots of data nuggets and lots of sort of strange things. So this is something that I certainly struggle with as well, is how do we, why not hire a professional who can, one part therapist, one part data analyst, who can answer questions and talk about the meaning of those things. You know what I mean? It seems like that would be a great...
Yeah, the short answer is this, but I think that's something we might eventually want to do, right? And it's something that I've been trying to kind of explain to people at work, which is that we don't have the capacity right now. We're not able to make quick sense of all the data. We're able to write code left and right. We're really good at that. But we're not really able to understand the data beyond what we have the experience to do. And a data analyst is probably the first person we need to hire. So maybe someday, right?
Any other questions? All right. Oh.
I'm curious if you have meetings specifically just to talk about the data and who's at those meetings.
I won't name names, but yes and no. I mean, we have like every museum does, we have senior management meetings, we have committee meetings, we have task forces and stuff like that. It varies pretty broadly. And of course we have board meetings, and a lot of those different things I just listed want to know the answers to the data nugget thing, right? They just want to know the update. The thing that I've been trying to figure out how to do in those kinds of scenarios is to present them with something new. And what I always kind of come back to is that it's easy to come up with the answer to X, Y, and Z. How many page views do you have right now? The hard part is coming up with the question that's next, like the thing that's after that. What do you do with that information? What's interesting about that? So yeah, we don't, I wouldn't say we have data meetings or anything like that. Maybe one day we will if we hire that analyst, but that's something that I think we're trying as an organization to wrap our heads around. Yeah, so thank you all.
I have a question.
Oh, uh-oh.
Do you think that you could get the position actually titled data therapist?
Oh, well, it is the Smithsonian, and there are rules, so maybe information technologist is what it will be. But we could call it data therapist. I think that would be that's a really good way to frame it.
Thanks, everyone.
Thank you.
Thanks, Mike.